Here we're going to look at a little more detail how your body goes about maintaining homeostasis. The reason why I have this picture here of someone balancing on the railing here is that's exactly what your body's trying to do. Trying to maintain this balancing act that's occurring despite changes that are happening in your body on a daily, hourly, minute by minute basis. So starting first with the basics of homeostasis. Well, we have our homeostasis. We want to be nice and level. But we have an imbalance that's occurring. Well, that imbalance needs to go through a receptor to detect that change. It needs to go to a control center of some sorts that then will send out an effector which will respond to that change and help correct that potential imbalance that did occur. Now, it's important to realize that homeostasis does not involve keeping conditions static. There can be changes that occur. What's important to remember is that it involves keeping conditions within a tightly regulated limits. So we can see we can change all we want in here, but if we went to go outside of this range, this is where we have issues that occur. So this homeostasis is keeping this very tight range, so slight changes are occurring, but it's occurring within a very tight range, this very tight balancing act. If we go back to our person balancing on the railing, you can waver a little bit. If you waver too far, you're going to fall one way or the other. Keep calm and maintain homeostasis. So let's now look at some examples. So there's a negative feedback model, it's called. So we have a specific body condition. We have something increasing, a gland releasing a hormone causing a lowering of that condition. Now, if we have a way, if something's getting too high, to lower that condition, well, if the body overcorrects and overlowers the condition, there needs to typically be another hormone that will then raise that condition. That's how our body is able to try to maintain that homeostasis, is to maintain, it's raising, it's trying to bring it down, it's too low, it's trying to bring it up. There. So let's take this as an example, particularly looking at the nervous system, tied in with body temperature. So if our body temperature, if we're increasing our body temperature, we have nerve signals that respond to that will cause our body to sweat and dilate our blood vessels. That will hopefully cool our body temperature. However, if our body temperature gets too cold, right, then we will need a way, we have different nerve signals that will cause us to shiver and constrict our blood vessels that will then hopefully cause our body temperature to raise so we're able to maintain that nice, consistent body temperature. In our brain, we have the hypothalamus, which is involved in regulating body temperature. So as a way of both lowering our body temperature or raising our body temperature. Connecting this with the endocrine system, we can look at the blood sugar. So our blood sugar level, if it gets too high, we have insulin. That'll be secreted by the pancreas. Body cells take up sugar from the blood and reduce our appetite. Then if it overshoots, we put too much sugar into our cells, and our blood sugar level gets too low, glucagon will be released, and this triggers hunger, and the liver will release glucose from the cells, increasing blood sugar levels. And that will hopefully, through this system of insulin and glucagon, it'll be able to maintain a consistent level or a consistent range of blood sugar in the body system.